Hello friends, in this video we're going to take another look at this Yamaha Natural Sound Stereo Power Amplifier model M-45. I looked at this in a previous video on the day that I got it. In that video I kind of did a basic checkout and found that all of the features of it worked. In this video we're going to pop the top on it, look at what's inside, and also do some real stress testing on this. This is a power amplifier from the mid 80s or so. It features 125 watts per channel. It weighs, I think, about 20 pounds. Overall it's a real beast. It's old enough to be considered vintage at this point, although in practice you know, you can make a 125 watt power amplifier that's just as good or maybe even better with current technology. Sometimes the vintage aspect of these things has to do with the cosmetics of them. This has some nice LED bars that jump up and down that we saw in the previous video, but other than that it's basically just a basic black box. The particular one that I've got, I had cleaned the top of it in the previous video and found that it has some minor cosmetic issues that can't be easily cleaned off. These are things that are, you know, might have to be, could be repainted or something like that if somebody really cared. But you know, it might be that somebody just stacks something on top of this and doesn't worry about it anyway. Gone ahead and taken the screws out of the top. It's got these four large kind of decorative screws on the sides, and it had these kind of two conventional screws on the back. The way this one seems to work, which we'll find out together, the way a lot of them work is you kind of pull it backwards a little bit. There's a lip here that would kind of lock under the front, and then maybe some side lips, and then voila! Turned it for better viewing. We'll start with the power supply section. Got an unswitched outlet here, power coming in here. Goes through this little board, which is this front panel control board. Probably the big feature of this. This is a purely mechanical switch. Since this is only a power amplifier, it doesn't have a remote control aspect, which we found in the previous video. So this draws zero power when it's off, as opposed to some sort of minimal power to operate the remote control system. Got this large transformer, which is the obvious feature here. Have to look at the outputs. We've got some inputs from AC through the interface board to the front power switch. Looks like three outputs of the transformer. You know, a ground and a plus and a minus. So black and two reds. There's this large board in the center that seems to be more or less symmetrical, suggesting it's kind of two independent channels. Got a heat sink on this side and a matching one on this side, with power transistors on each, counting 4 on the bottom and 1 kind of in the middle with some other interface chips. So maybe that's actually there might be 2. Maybe this is some sort of preamplifier or something that drives the other ones. So you can see, just cutting right down the middle of this, that we've got what amounts to 2 independent power amplifiers that are you know, constructed together as one piece, primarily through this main board. Now here, this is the back side of this switch panel and level controls. So you can imagine that the audio input comes in here. In fact, let's trace that. We have our audio input here, a little bit of signal conditioning, RCs, keep out high frequency noise. Travel over here, we do switching and volume control, or actually level at this point. We've got this board, which is primarily the power display board. In fact, that's probably all that it does, or may have also some driver circuitry that runs these indicators. There's a power indicator, a protection indicator, and this auto class A light, which is goes with this switch. I haven't worked out what this auto class A is all about, but I see on the spec sheet it says auto class A operation range 10 watts. So maybe that's some sort of highly linear function with lesser power output. It's kind of a guess. We have these large transformers here, probably, or no, I'm sorry, those are not transformers. These are actually large capacitors, 22,000 microfarads, 69 WV. So those probably have to do with the power supply. Let's say this is the power supply conditioning section. Actually, we can deduce that from the fact that these three wires from the transformer go straight in there. Maybe this is some sort of voltage regulator or power transistor that's associated with that. Here are some smaller capacitors that are still pretty large, and other various smaller capacitors, some power resistors, you know, signal transistors here, that type of thing. So one of the design features of this, you can see, is that it has no cooling fan, and there's actually a lot of space inside this box, empty space, you know, and I think what's going on here, rather than try to make this smaller, which is maybe possible, but they're taking a lot of advantage of the convection cooling to avoid the need of a fan. So you've got these fins that are going horizontally that are going to allow rising heat to come out and ultimately through the top, which has a grid of holes on it. The transformer is going to generate some heat of its own because it's not 100% efficient. That can maybe get conducted into the bottom shell. There's a large sheet metal piece here, and maybe some cooling just off the top of that also. And of course we've got symmetry on this side where we've got the same type of fins here. Probably the watt meter board doesn't draw a whole lot of power, but in any case it has a kind of a vertical placement that allows air to come up through here. And to make all that work thermally, we've got fins on the bottom so air can freely come up through the bottom of this and circulate out through the top. And a lot of audio components have some sort of feet like this where you can stack them but still have airflow through there, and that's you know, the feet are kind of a convenience anyway. It makes it look nicer, but in particular it also has a kind of a thermal purpose, which is to let air get underneath this so it can rise out the top. And then if you have another unit of some kind stacked on top of this and it has its own feet, then that same sort of thing can keep happening, and maybe air gets in from the side and the front. Now back to this particular unit itself. Let's do a visual inspection and see what's going on. Got a lot of dust. I'm going to clean that off separately, but that's not any kind of real issue. It's just kind of a good thing to do every 30 years is clean the dust out of it. You can see the tops on all these capacitors are intact, so there's no reason to believe that any of these capacitors are bad. The smaller capacitors basically don't go bad, and modern capacitors in a nominal situation really last for decades anyway. Some of the older types of capacitors used in tube equipment didn't last forever, but this type from the 80s probably will if they're not abused in some way. So on a visual inspection, this looks like a very solid unit. Nothing to be concerned about here whatsoever, just ordinary dust. Start cleaning with a little vacuuming. Well, I didn't really pick up too much. I think it's because we really don't have all that much of dust there loose. It's actually kind of surprising after all these years. I'll just do a little light wiping. Now this piece behind the big capacitors, I realized later on, is a full wave bridge rectifier. That's right next to these 3 power inputs from the transformer. Really the way to do this ideally would be to blow it out, probably empty a whole air can on this, so I'm just going to use the air can on these major heatsink fins, kind of to avoid making too much dust in my little world here. Maybe do the transformer and the circuit board. I guess I'm ending up doing the whole thing more or less, except I'll just leave the chassis as is. If archaeologists ever discover this in the future, they can maybe gain some information from the dust inside. Okay. Now we're ready to put the lid back on it and do some performance tests. Here are the load resistors I'm going to use to test this with. These are 8 ohm power resistors. I bought both of them on Amazon for a total of about $6. I soldered on a little bit of standard 20 gauge zip cord, like you plug in a light with, and also some alligator clips out of this set that costs about $2 at Harbor Freight. Here's the test setup that I lashed together for this. These are some 8 ohm power resistors, a pair of those hooked up directly to the speaker outputs. Got an AC voltmeter connected across one of those. Got the inputs connected to channels 3 and 4 of the oscilloscope, and I've got oscilloscope probes on the load resistors so we can see everything that's going on here. Got everything already powered on and ready to go. Using my phone as a signal generator. I've got 1 kilohertz tone coming in as kind of a mid-range. Got it turned to a low volume. I have these level controls set on full on the amplifier. So we turn that on. I'm going to drive the volume level coming out of the phone up a little bit. We see bars moving around, and we see those on the oscilloscope. So I'm at full volume of what the phone can produce. So I'm up to 8 bars out of 10. Each bar is worth 3 dB according to markings, and I'm going to make a table of measurements to validate that, but mainly just to show that the receiver is working. Now at this level, I don't have these properly mounted to this heat sink. They're just kind of sitting on there because this is a temporary rig. But at this point, after running for a few minutes at 8 bars, this resistor is getting noticeably hot to the point where I couldn't keep my finger on it for real long. 12 volts AC coming out of the unit. That corresponds to, you're showing this bar at minus 10 dB relative to full scale of what the unit can do, and 12.5 volts here. So this scale on the right is volts, this scale in the middle is dB. And I'm going to go ahead and shut things off for the moment to let the power resistors cool down, because they're probably getting, let's just see if I can hurt myself. Okay, don't want to do that for too long. We can shut it off at the phone, probably the easiest thing. So we can't drive this thing to its full power with just the phone. So I'm going to add in a preamplifier that I have, which will give me some more voltage gain. I've added in this Adcom preamp into the chain, model GTP-502. I've used this as my primary stereo receiver for over 20 years. I've got the power level set right now for the whole system at 1 bar. So we're going to go up in power using the volume control on the preamp. See how far we can push it. So I'm not going to leave that running for too long to heat up my power resistors, but you can see that we get all the way to the 0 bar, which is essentially full rated power of this unit. Turn that back down to 1 bar. Now these are too hot to touch it more than a tap, so that all makes sense. Let's look at our voltage for full power. 45 volts AC, 46. Turn that down again. Something smells toasty, not surprisingly. As another test, these level controls are marked in dB. So I'm at 0, which is full scale. I could go to 6, let's say, on each. I'm going to go up again in power to get a few bars. I'm going to go to about 9. We should see 1 bar go away on that side. 1 bar go away on this side for 9. I'm going to turn down the total volume to move both bars. I'm going to turn these both up full way. I see that these bars don't quite track. They're supposed to be getting exactly the same signal, but it's actually through 2 different signal chains that originate at the phone. So now, as a further test, let's go to just a few bars. This unit is rated down to 20 Hertz, but I know that my phone can only go down to 30 hertz, or at least with this application. So I'm going to 30 hertz. So with this same setting, I'm going to go through different frequencies and see what we get. So let's go to about 10K. I know that'll work. And here we've got 0.524 volts. So I'll just drive down the units to 1K again, 1.7, this is 30 hertz, 1.8, go to about 500 hertz, 1.8. Let's find the point where it seems to be rolling off. So something in the signal chain is rolling off a little bit. I'm not really going to track that down. You can see on the inputs, which are the bottom two lines here, that the phone is rolling off. So let's go back to the point where they don't roll off. So it begins to roll off about there, which is 8K. Actually, that sounds familiar. So let's say we go to half of that, of about 4K, 1.3 volts. So I haven't got everything calibrated enough to know how much of this is the amplifier versus the rest of the signal chain, but I don't have any reason to believe that it's the amplifier. Now, just for fun, let's go up to higher frequency that's quite rolled off on the phone. As you can see there, I've lost my bars here, which makes sense. Well, these resistors are getting quite toasty, so we're going to drop our power level and save our resistors. In this case, I'm using the same setup, but I've got the speakers connected to this B set. So I've got the A set turned off, which aren't even connected, and the B set turned on. Here's the scope picture with about an 8 kilohertz input and 4 bars showing. I'm going to turn up the volume on the preamp, and we go to full bars. Turn on my voltmeter. We got 42 volts. We'll do the auto range on the scope here. Both of these are getting quite warm. Got some distortion somewhere. We go down. Whoop, we're starting to smoke. Better stop. So after a quick check, it turned out that the ground shield on my scope probe was touching this power resistor, so it was getting smoked by the heat. It's not a electrical problem per se, more of a setup problem. We've got just a little bit of scorched ground, but I can live with that for the sake of science. So we'll turn it all back on again. Crank up a few bars. Okay. Here it is cranked up and distorted. Just for fun, let's go down to our lowest frequency of 30 hertz. The lowest frequency that the phone will do, at least. We'll go up to about 5 bars. Redo the auto feature on the scope. Let's see, I've got some more wires touching heat over here. That's not good. Okay, well, before I toast anything more, I think we better stop here, but I got out of this what I wanted to, which is that we proved that this Yamaha M-45 amplifier works perfectly in every regard, that I can measure it here in my lab setup. So we'll end with that. Thanks for watching, and bye-bye.